Hello, I'm Ved. For this activity, the statement is circuit switching versus packet switching in computer networks. We choose this problem because it is fundamental issue in networking. The way switching is performed in a network has direct effect on performance, including delay, throughput, and reliability. This problem matters because without understanding switching methods, it is very difficult to appreciate why traditional telephony worked the way it did and why the modern internet is structured as it is. Now, let me show you our final concept map. At the top level, the map starts with switching methods, which branches into two main categories, circuit switching and packet switching. Now let's see about circuit switching. This technique sets up a dedicated path from the sender to the receiver and guarantees consistent delay and predictable communication. This is ideal for real-time voice communication, such as traditional telephone calls. In fact, we included the telephone network as a real-world example of circuit switching. Now we will see about packet switching. This technique breaks data into packets, each of which travels independently. It is flexible and efficient, especially for large and varied data flows. It is used by the internet, enabling services like voice over IP, video streaming, and online gaming. Our concept map also includes crosslinks to show relationships. For example, one crosslink connects delay and throughput trade-offs. Circuit switching minimizes delay but is not efficient for work transfers, while packet switching increases throughput, can introduce variable delay. Another crosslink shows that real-time voice is supported better by circuit switching, while bulk data transfer and web browsing are handled better by packet switching.
Krish Mahindra and my ID number is 24CS054. Let us discuss some point about defense and let's revision it. When we present our first version, we received helpful peer feedback. Based on that feedback, we made two major changes. We added real world examples. Initially, our concept map was too theoretical. So we include traditional telephone networks for circuit switching and internet streaming and VoIP for packet switching. These examples made our concept map practical and relatable. We expanded the trade-offs, we added details about delays, relatability, and throughput because this helps us compare the strengths and weakness of both techniques more clearly. At the same time, there was one suggestion we decided not to include, adding quality of service. We defended this choice because quality of service is actually an advanced performance optimization mechanism built mainly on top of packet switch networks. Our chosen problem statement was specially about fundamental switching methods, not about higher level networking performance management, including QoS, would have gone beyond the scope and confused the focus on our concept map. That's why we kept it out and we believe this was the right decision. Thank you.
Hello, my name is Prince, and our problem statement for packet switching versus circuit switching. While working on this activity, we also reflected on what we learned. At first, we had a micro concept. We thought packet switching always leads to more delay, but then we realized that this is not always true. Delay mainly depends on convenience. In fact, packet switching is actually more efficient for bulk data transfers. The most variable insight we gained was thought peer review. We realized how important real world examples are. Adding those examples made our concept map much clearer because they are connected theory to practical scenarios that all of us could easily understand. Another important takeaway was the effect of teamwork. Working as a team made a huge difference. Each of us contributed ideas and correction by combining our perspective. We ended up with a stronger, more accurate, and more complete concept map than what any one of us could have done alone. In conclusion, this concept map shows the STL difference between circuit switching and packet switching. It also explains their applications trade-off and practical uses. It highlights why circuit switching was once dominant for telephony and why packet switching is now the backbone of the internet.